This is the future of teaching. Welcome to Group 1. The presenters are Brent Sweeten, Logan Kilgore, Jack Rodriguez, and Hayden Clark. We are presenting on behalf of the teachers, and we were assigned the task to create a vehicle that best supports our end users, keeps the passengers safe, and can travel harsh terrain. The design must be creative and innovative, also solar powered, and holding a learning environment for children to learn in difficult to reach areas. The needs in our vehicle are to be innovative, within budget, sustainable, safe, has storage, and supports educational efforts. Some wants are aesthetically pleasing, comfortable, inspirational, easily accessible, and able to reach high speeds. Now for our design, we have included things such as whiteboards, shade structures, solar panels, and storage to hold the important colored pencils. Now in our design, we have used solar panels, and we have 3 solar panels that are 5 volts. These solar panels are what we use to drive our vehicle and are the main source of energy. Our design has whiteboards as shown on the side of the vehicle, as long as storage capacities and containers also on the side of the vehicle. Now, we have plenty of storage and abilities to hold any school supplies such as laptops, colored pencils, paper, anything. Now our whiteboard and our shade structure allows for better and more engaging teaching environments.
Now moving towards the gear section of our design, the power behind it all. As you can see in figure 1.2, we have a rough sketch of generally what we're looking for in our transmission. Now, keep in mind, these proportions of these objects are not very accurate, to say the least. This is more just serves the purpose to get the rough sketch out there. Now, as you can see, we have our prototype transmission with a gear ratio of 2:1. Now that gear ratio is subject to change in the future. This is due to our increased weight of our vehicle coming in at about 1.2 kilograms. So therefore, we possibly might move to a 3:1 gear ratio in order to ensure that we have more torque with, in return, less speed. But for our needs, it may be necessary.
So my part in this was the automation portion, which, as you can see there on the left, is our circuit diagram. We are going to be using an ultrasonic sensor to help us determine the distance from 2 points, mainly from where our car is to something in front of it, because we don't want to just crash into something. As of right now, this is hooked up to Arduino, which is also hooked up to 3 LEDs, which determine how far away we are from something. The first one is on a dim light, just always to show that the car is on currently. And as you get closer to another point, all 3 turn on. Eventually, coming up in the next couple of weeks, we want to incorporate our motor into this circuit and have it so that if we get within a few, or I think that we're going to go with 15 centimeters, the motors will automatically turn off so that we don't hit the thing in front of us. And then whoever's driving the car can take over and navigate around the obstacle safely. Next is our materials and cost. And as you can see, we totaled it out to be $45.50 times $1 million, so it's $45,500,000. We have 3 solar panels, as we showed before. One of them is free, given to us by our lovely president. Our transmission design is on here too, just we're going to change it up a little bit from what it is on here currently. We just haven't done so yet. We have our battery holder, and our battery is included with our materials already. It's not on this sheet so far. We can add it on there though.
Hello, we collected data through an AHP table. The AHP table assigns weights on different criteria that we determine to be useful and necessary for our vehicle. The weights are calculated by dividing category weight by actual weight, so it's basically a ratio, and innovation, safety, and storage were given the highest weight by evidence influence from the teacher, logistics manager, engineer. We got 21% for innovation, safety 23%, and storage 17%. We also use a design matrix, and in conclusion, this vehicle provides mobile and portable education to people who are less fortunate in more remote areas. This significantly produces renewable energy and sustainable energy at a high rate with 3 solar panels strapped to the top of the vehicle. This provides plentiful seating and is very good at promoting storage materials. Students will be able to be educated and learn from any location and time, and this will make learning fun and more accessible anywhere in the world. And here's the references.